All right, so we're gonna go ahead and finish the last part of the Unit 7 Lesson 1 note guide. And here we're gonna start with, this should be about the third page of your note guide, I would think. But just find your note guide, find this, and we're gonna just start here on this page where it's talking about shapes of distributions. Okay, so we can describe the shape of distributions as symmetric, skewed, bell-shaped, bimodal, or uniform. Here is a dot plot, histogram, and box plot representing the distribution of the same data set. Okay, so in class yesterday we talked about the dot plots, and we also even talked about and constructed the box plot. But the histogram is just another way to represent data. In a histogram, you see like here the number 6 through 8, and then you have this bar. It's different from a bar graph because a bar graph would only have like one bar for each thing, such as if I was wanting to say, what's your eye color? Then I would have like the color blue here, and then I would have a bar to represent that. But a histogram is a little bit different. A histogram says, but how many pieces of my data are between the numbers 6 and 8? So this bar comes up to 1. So that means that there was one piece of data between 6 and 8. And if I look up here on my dot plot, between 6 and 8, there was just 1. Okay, and you might be saying, well, what about that 8? There was 1 there. Now that number would be included in the bar between 8 and 10. So all the numbers between 8 and 10, not including the 10. 10 would be included in the next bar. All right, so here, this is called a symmetric distribution. And the reason why we call this symmetric is because if I was to cut this dot plot down the middle, it is about the same on the left side and on the right side. Okay, as far as you see, like the dots are symmetric on each side of that middle. Okay, now, because if I was to draw a curve over that distribution, over that dot plot, it makes this bell-shaped curve. So it goes up, comes back down perfectly. You got the peak up here at the top. This is also known as a bell-shaped distribution. And when you all get into advanced algebra, you'll be learning that we're going to do some more things with these types of distributions. We'll just save that for advanced algebra. Okay, so over here in this box, I ask, what is the best measure of center for the shape of this distribution? Well, first, let's go ahead and look at this here. This histogram is also, you can say it's roughly symmetric and bell-shaped, even though it's not perfect. And then also, if you look at the box plot, you see how like everything in the middle is here. It's nice and even. And then even my maximum and my minimum are roughly it's like everything just looks equal on both sides. That lets me know that this is symmetric and also bell-shaped. Now, what is the best measures of center for this shape? Well, there are 2 measures of center that we're going to be analyzing in this class. One is mean, and then the other one is median. Okay, so the mean of this data set, remember, is like the average. You add all the numbers together and divide. But the problem with some distributions is, and I always like to equate this to your grades. Let's say that your grades, that you have all 100s and you make 1 0. Okay? All right, and matter of fact, I can even do that example. So let's say that I have 3 100s, and then I just messed up one day and I just had a 0 on something. Okay? Now, the way that we calculate your grades now, that would be X, your X bar, mean. I would add all of these together and divide by 4 because there's 4 grades. That would be 300 over 4. Which, y'all, that means that you have a 75%. Isn't that bad? Isn't that just because of this one? Now you go home and you tell your parents, well, I was making 100, but because of this 1 0, now instead of an A, you have a C. Okay, this is why you probably want your classes to be based on medians. Okay, so this is if you're looking at the mean. What if we're looking at the median? Okay, Well, I put my numbers in order from least to greatest. That's what you do first with median, or greatest to least, it doesn't matter. And the median would be the number in the middle. Now, in this case, the number that's in the middle is in between the 100 and the 100. Well, two quick ways that we can think about that. What number is between 100 and 100? It's just 100. Or I can add these two together, okay? I can add these two together and then divide by 2. 100 plus 100 divided by 2 is 200. Divided by 2, is 100. So the median is 100. So wouldn't you want that to be your grade rather than the 75? Okay, now, just so you know, if your distribution has an outlier, remember we talked about that yesterday, outlier, or the data is just somewhat not fixed, it's not, the mean is not going to be that middle number, you may not want to rely on your mean to tell you much about the data set, because outliers are heavily influenced by outliers or big data sets with like big numbers at one end, at the other end. It doesn't really actually tell you the trueness of your data, okay? But with a median, an outlier doesn't really affect it, because see, look, does that 0 even impact the middle? No, it does not. Okay, so when I'm having to decide what's the best measure of center for this, if your distribution is bell-shaped or symmetric, you're better to go with, because there is no big outliers that is going to affect your mean, you're going to go with mean here. Okay, so bell-shaped distributions, you would use the mean to describe that data set. Now, what about the measures of spread? Now, we got two measures of spread. You have your standard deviation, or you have your IQR, okay? Which one would we use here? Well, I'm gonna just tell you right now, if you pick mean for your center, then your spread, you're gonna use your standard deviation. They go together, okay? You're not gonna use mean and IQR, okay? That's just because you know that median is a part of, finding your IQR. So those two go together just like mean and standard deviation go together. Okay. All right. Now here, a skewed distribution. This is skewed because most of my data is up here on this side, and then it kind of goes down. And so if I was to draw a curve over that, it would look something like this. And that's not bell-shaped at all. It's going down. And this would actually be called skewed because it starts off high, ends low. And the opposite can happen also. It can kind of start off low and then end high. But this is an example of one that's skewed to the right, because you'll learn also that if you have a tail, which this has a tail end, we would say this is skewed out to my tail. So it's skewed out to the right for this graph. You see that histogram? Skewed. And then also, you can see here that most of my data falls down here by the box and then kind of wavers out down here at this end, at that maximum. So what's the best measure of spread for this? Because most of my data is actually over here, and these are, they're not outliers, I don't think, but if I was to, calculate those in, those numbers are going to draw that mean out farther than where most of my data is, okay? So that skewedness will always, you would want to rely on your median. Remember that 100, 100, 100, 0? Yeah, we want that median when we have data that's very much apart from what the normal trend is. What would be the spread? We're going to rely on the IQR, okay? Because again, median and IQR. All right. Now here we have a uniform distribution, and in a uniform distribution, it means exactly what it is. Everything looks the same. If you look here on this dot plot, every single value has 2, and so it's like it's even, and look at that Boswell's plot. Everything is even from here to here is the same interval on each one. So if we have that, let me see. If we have that kind of distribution, this uniform, what would we use for center? Would we use the spread? Would we use the mean, or would we use the median? Well, I think that in this case, we would use the mean because it is about equal on each side, okay? It's symmetric, and so when we have that symmetric, it's symmetric, it's uniform, but it's symmetric, we would want to use the mean. And then because I use mean, I will use standard deviation. Okay? Now, down here we have a bimodal distribution. And what bimodal means is that we have like two areas where it's actually peaking. Unlike the symmetric, where you have that one peak, you have more than one here. Like most of your data fall on this side, okay? So sometimes a bimodal distribution has most of the data clustered in the middle of the distribution. In these cases, the center of the distribution does not describe the data very well. Bimodal distributions are not always symmetric. Okay, so you see how this is just nice and a good example. But sometimes you can have bimodal distributions where it has like two peaks like this, where it's not looking nice like this. Okay, so in that case, for most cases of bimodal, you would use the median and the IQR for this measure of spread. All right, now we're on to part 4. And so for part 4, I am going to pause. I'm going to link another video so that y'all can do part 4.